Hi. Gita and I would like to thank you all so much for coming and joining us today for our CNR Research Networking event. We are really excited that we have 8 talks for you today. So I think we're very excited to hear from the breadth of different methods and designs of studies to hopefully get some really interesting conversations going. And maybe spark some new collaborations between some of our kind of clinical colleagues and our researchers. So just to tell you a little bit about the format for anyone that hasn't been before. So to fit in 8 talks, we've had to keep them to time. So everyone will basically be speaking for 5 minutes, and then we'll have 2 minutes for questions afterwards. And then the idea is that at the end of everyone's talk, we will allow everyone to kind of network around the room. So we might ask our speakers to kind of position themselves in various locations around the room, or maybe outside as well, if it's looking like there's a lot of us. And we'll have 20 minutes or so just as an opportunity for you to just very informally have a chat to anyone that you thought you heard something that you were interested in and would like to hear more about. So it'll be very relaxed, and obviously we'll invite everyone for some drinks and crisps afterwards. Okay, so whilst I load up the next talk, I'd like to invite, please, Chandani Shah to come, who's coming to us from Homerton.
Good evening, everyone. Thank you, CNR, for this opportunity. I'm Chand, neurophysiotherapist from RNRU Homerton Hospital, and this is my MSc dissertation project with UCL. So this mixed method service evaluation explored factors affecting therapy intensity on level 1 neuro rehab unit. This project more of emerged from my long clinical challenge in practice. How do we deliver therapy intensity in real world to have meaningful recovery with our patients? So we know that stroke remains a major cause of disability, and with increase in survival rate, there is increased demand on neurorehabilitation services. There is a percentage of stroke survivors that require inpatient rehabilitation, and a smaller subset require level 1 specialist neurorehabilitation. And these patients have complex physical, cognitive, communication, social, and behavioral needs, and that makes their rehabilitation particularly challenging. So I evaluated one such service called RNRU, Regional Neuro Rehab Unit, which serves 2 million population in Northeast London and Essex, and 79% of its admissions in 2023 were due to stroke. Now we know that global stroke rehabilitation guidelines emphasizes therapy dosage, which in the UK until 2023 was 45 minutes of each appropriate therapy 5 days a week. And this is being audited on UK stroke units using SNAP. But this is not the case for level 1 units, despite having high stroke admissions. And literature suggests that the factors affecting therapy intensity are well researched on acute stroke unit, but not on level 1 unit. And this was the practice gap for this project. So the core problem is that we know that intensity matters, but we do not routinely evaluate therapy intensity practices on level 1 units, and we do not fully understand what factors affects its delivery in level 1 settings. So this project aimed to answer 2 questions. Does RNRU meet recommended therapy dosage? And 2, what factors affects its intensity according to its MTT? But before we go into the detail, it was important from the literature to understand what intensity constitutes. So literature suggests that beyond therapy duration and frequency, task repetitions, patient effort, and task difficulty are critical components of therapy intensity, and they must extend beyond therapy sessions into patients' real life 24/7. And this is particularly true for those level 1 complex patients where therapy duration session might not equate to true intensity. So this mixed method service evaluation audited 43 stroke patients admitted in 2023 on RNRU with motor recovery goals, and audited against the 45-minute therapy, 45-minute guideline. And this informed semi-structured interviews with 19 members of RNRU that included doctors, nurses, therapists, therapy, and nursing assistants. So the results, the quantitative findings were quite clear. The unit did not meet consistently the therapy dosage targets, and there were variations between different disciplines, which was very much in line with the SNAP data from the last decade. But the qualitative findings had deeper explanation. The thematic analysis of staff interviews identified 3 themes: intensity as a concept, intensity as a process, and intensity in action. So the concept domain highlighted that staff did not share a holistic understanding of what intensity actually means in practice. For some, it was time, and for others, it was effort, challenge, and activity beyond sessions. And this kind of affected how intensity was prioritized, planned, and delivered in practice. The action domain kind of highlighted barriers such as staffing fluctuations, patient complexity, competing demands, workload pressures, and organizational processes, whereas the action domain highlighted more of wider systemic and cultural issues such as divided ownership of rehabilitation and underuse of families, self-management, and staff support workers. But overall, most of the findings were in line with the stroke literature, highlighting organizational processes, staffing constraints, and the institutional culture. But the main differentiating factor of this project was that lack of shared understanding of what actually intensity means was a foundational barrier. The project also kind of highlighted things like service process issues, the role boundaries, and divided ownership of rehabilitation. So in conclusion, the service evaluated did not meet the target for therapy dosage. The delivery was affected by complex interplay of patient needs, staff workload, organizational process, and institutional culture. The major barrier was that lack of shared understanding, and the recommendations include that it is a must that we define intensity properly as a team, prioritize it to deliver more of a therapy 24/7 therapy model. So the take-home message is that we need to understand intensity better. We need to prioritize it to optimize our processes, and to deliver it better, we need to understand it as a team to integrate more of 24/7 model. These were my references. Thank you for listening. I'm open for questions.
Thank you. That's very interesting, Chandani. Any questions?
Yeah.
Just give us a brief definition of the intensity, because it's bound to be based on what you've read about it already.
So I think we all, and the guidelines kind of focus on therapy duration, and I think that is more of a dosage, but it's just not the length of the session. But if we were to kind of, in an ideal world, see intensity, then it's the length of the session, but the number of sessions we offer, but also how we deliver those sessions. So is it of the right challenge for the patient, if it is too easy or it's too difficult? And how do we modify our input within those sessions that is targeted to patient presentation, so we are challenging them enough for neuroplastic changes, but also how much patient effort, and that effort and task challenge kind of goes hand in hand within that session, and that kind of determines clinicians' reasoning on how we kind of have the duration, what rest breaks we give them. So frequency is just not about how many, but how we deliver. Can we do half an hour sessions twice a day, so like a block practice, or do we do much more one at a go? And it's very patient specific. We need to adapt our approach patient specific to actually truly deliver intensity. But this was more about even those patients that we think that can, tolerate that ideal 3 hours of practice and 6 hours of activity. Even for those patients, are we as level 1 units delivering that? And the answer is no.
But it's interesting you say that it's going to have to be highly individualised. And how do you do that with a definition? How do you individualise all of those 3 things? Is there a way that you actually look at things like time, like challenge, as you were saying? How do you monitor challenge? Going back to the outcome measure question earlier. So that's very interesting things to think about when you actually
totally. And and there is no studies, when I looked at it, there's no studies who has looked at intensity as holistically. So there's so much scope to study intensity actually in practice.
There you go, that might be a PhD. Thank you, Chandani. Thank you very much. Could I now welcome, Shu is coming up to talk about machine learning for spasticity evaluation, preliminary findings from her systematic review. Sorry, Shu, I'll get that out for you. We've got another double act. Sorry, I didn't realise. Sorry, hi, Jack.
Hello, thank you. So my name's Shu, I'm a physiotherapist. I'm Chuck, I'm a research fellow at the stroke department at Queen Square. So we're here to share our preliminary results from systematic review of using machine learning in spasticity evaluation. So spasticity is highly prevalent across all neurological conditions, severely limiting patients' activities and quality of life. Robust spasticity measures are crucial to monitor disease progression and evaluate our treatment response. Modified Ashworth and modified Tardieu scales are our established clinical measures. However, they do have limitations. For example, inter-rater reliability remain problematic due to its subjectivity, especially in the lower limbs, and their grading cannot detect subtle changes in spasticity. To address this, some researchers are beginning to use machine learning to enhance current measures. Algorithm models can reduce some bias and produce high-resolution quantitative continuous metrics to capture changes we may otherwise miss. So how do we do it? Our search strategies was comprehensive and bridged both clinical and technical literature. We searched about medical databases, including PubMed, Embase, European PMC, alongside engineering databases like ACM Digital Library. We also included broad scientific databases such as Web of Science, as well as evidence-based resources like Cochrane Library and Gray Literature. Our search terms combine two key domains, spasticity and its related terms, and machine learning terminologies. And this dual approach was essential to capture interdisciplinary nature of this field. So from over 32,000 initial records, we screened down to only 24 papers based on our broad inclusion criteria, which is listed here. Regarding quality assessment, we used ProBuster. It's a tool assessing risk of bias and applicability, it's a difficult word for me, in clinical prediction model studies. The result shows 29% of studies were low risk, 58% moderate risk, and 13 at high risk. A critical red flag emerged here. Only 8% conducted external validation. Now, results.
Yeah, thank you very much. I'll give a brief overview of our headline findings. First of all, as you can see, there is a clear trend of increasing interest in machine learning in the last couple of years. And in terms of how the algorithms actually work, most studies take data from devices such as SEMG or other sensors, and then they process these data into specific features, and then they feed these features into a machine learning model, which then are used to make a prediction, such as a specific MAS score. Stroke is the most common conditions being studied, and there are other conditions, as you can see on the screen, that are present in our other studies in our review. And here is a snapshot of our results. We only look at the papers that use machine learning to predict a specific MAS score, and each bar on here represents a different machine learning architecture. As you can see here, many studies achieve quite a high accuracy scores of over 90% in predicting a specific MAS score, but there is a large variations between different studies and between different architectures. And we concluded several insights from our review. Firstly, there is the question of whether using machine learning to predict MAS score is actually the right question to answer. The modified Ashworth score is inherently, at least partially, subjective, and therefore machine learning models that are trained to predict these scores may only be digitizing or reinforcing subjective judgment. And secondly, most of these studies use custom-made or high-end devices, meaning that their results are less reproducible and are not yet translatable to clinical practice. And finally, there are many specific nuances around the machine learning algorithm design that we do not have time to go into here. However, we observe that there are some emerging techniques of using hybrid model, where cases are first analyzed through a clinician-designed algorithm before being fed into a machine learning algorithm for pattern recognition. This highlights a potential from a more fundamental algorithm level of recognizing a human-machine collaboration, which is an area that my colleague will reflect on further.
So we just want to do a little bit more reflection on this project itself. So we see this project as an opportunity to begin embracing these technologies and to welcome them into our healthcare system. It's helpful for us as clinicians to understand these tools that we can later maybe apply them in our neuro rehab in the future. Second, what emerged from literature is that machine learning represents, as a tool, it builds on existing clinical and research measures, enhances diagnostic accuracy. However, it does not really replace current our clinical expertise. Lastly, this review represents a good model for interdisciplinary collaboration in which clinicians and technical specialists blur the boundaries and bring their expertise together to enhance the measure. And that's about it.
Okay, just stay there. I'd like to put it to the floor if anyone has any questions that they'd like to ask our two speakers. No? Okay. If not, well, I've got two questions, just quick ones. The first one is, just in your systematic review, you started off with 15,000 studies and then went down with your eligibility criteria to 70-something and then 20. Yeah. I just wondered, how did you actually, physically do that? And did you need to use AI to do that for you, or did you do it manually?
I definitely went through everything.
15,000?
Yeah, it took me a long time.
Wow.
Yeah.
Okay. That's incredible. Okay. Well done. The other.
I suppose we went through the title and the abstract of all the papers, not the whole paper. We take a lifetime.
Because the first stage, what we did, first stage was went through the titles and abstracts. And then narrowing down to 76. Okay. And then all 76 papers, we read them all.
Brilliant. The other question is also about an N question, but it's more about the publications then that you were looking at. Because you kind of think of machine learning, you need to have a really large N to actually even do machine learning, because you're kind of predicting based on example data sets and things. What kind of N are we talking about for some of those example studies? I just think clinical studies are never going to reach anywhere near that level. Can you comment on that?
Yeah. Most of them are quite small. I think most of them that use a device, pretty much all of them are less than 100, so between 10 to 100. And I think the smallest ones are less than 10 even,
really?
Just because of how complex the devices are. So a lot of them are still exploratory. And I think there is still a lot of questions about how it can be used.
Yeah, okay. Yeah, a quick one from the audience.
Since you said that mass modified Ashford scale is very subjective, and so everyone will do something different, so probably your AI model actually will not work because the initial data is very noisy. Wouldn't the result from the study will be, let's create new specificity score?
Yeah, good question. I thought about that too. But then reality is, in fact, all these researchers use the data from modified Ashworth or modified Harju to train the data to compare. So I don't think that's why I feel like we cannot, it's not possible for us to give up the clinical measurement now. But machine learning is add onto another layer to see, okay, how can we improve the accuracy of what we do now? The devices they use in these studies of very high end, it's highly unlikely you use them clinically unless there's advancement of technology, you can apply them clinically. But still at the moment, we may need to look at how to improve MAS, or alternatively, how do we improve our understanding of spasticity to find out what exactly spasticity is.
Thank you.
Thank you.
Okay, so our next speaker, which brings us to talk number 7, is Ivan Isakov, who's someone that's coming to us from industry. So it's not just NHS clinicians and academics that we invite to these talks. Just bear with me.
Perfect. Great. Very excited to be here. So I'm going to talk a bit about immersive functional electrical stimulation for motor recovery in stroke patients, and what we've done in the last half a year in our usability and acceptability pilot in collaboration with both clinicians and scientists. So I'll start from what we we at Valkyrie Industries, we do. We work on functional electrical stimulation. Some people seen the devices. I have them in my hand. They're very easy to use wearable FES devices. You can use several channels in parallel in order to use FES for your functional tasks training, or for your recovery from spasticity, or for anything that you want to use FES for. The good things about our devices is they're wearable. They don't have any cables. They have connection with mobile phones or with computers in real time. So you in real time can control the stimulation intensity, pulse width, frequency, and we can make them motion aware. So we can connect them with either virtual reality headset or cameras that know how you're moving in space, and based on that, add or remove electrical stimulation, thus potentially helping with your functional task training. So,
I never knew I had so much fun.
So this is just an example of what's actually happening. So you see this lady, she had several small strokes. She had spasticity, you see, in her left hand. She cannot really open and close her hand. And what we have here, we have two devices, one of the extensor, one of the flexor, that helps her open the hand in the right place and close the hand in the right place. So she sees various cubes in virtual reality, and stimulation kind of opens her hand before she grabs this cube and closes the hand when she needs to. And then when she moves it in the right place, again, stimulation helps her open the hand. So it kind of connects her thinking, now I need to open my hand, and stimulation would help her open the hand. That's one of the small game that we created. We created several of them, and over the last 6 months we were working with King's College guys and St. Thomas's and Hobbs Rehabilitation on the grant supported by Innovate UK. So currently it's preliminary data. We have 18 chronic stroke pain survivors with this age. We will probably have around 30-35 people by the end of the study. Tried single wrist movement, so extension and flexion, and the participants were targeting virtual reality targets, and FES was helping them to open, as I mentioned, open or move the hand left and right. The limb impairment was assessed before the training, and usability and acceptability was measured afterwards. So here are the preliminary results. The spider graph in the middle shows the usefulness, usability, enjoyment, intention to use, and ease of use. And you see it's pretty high levels for all our participants. The Fugelmeyer upper extremity assessment allowed us to try different people with very wide range of mobilities, from very severe to mild. And what's very, very interesting, which we think, is that graph on the right. You think, oh, it's just scatter plot with no real correlation. And it's good, because you can have people with very, very low mobility enjoying this experience, and people with high mobility enjoying experience. It's usually concerning. You would think, oh, these people with very severe stroke, probably they will not use virtual reality, FES together. They'll be fatigued very, very quickly. In our case, they used it for half an hour, and they enjoyed it, which is great. It's a great point in our research, from which we'll then go into more longitudinal efficacy study afterwards. So these are some testimonials from both patients and clinicians. Very easy setup. What's very good for us to see is a lot of therapists actually don't use FES, and they're a bit hesitant because it's technology, devices, and they're actually very happy because it's so easy, and the patients as well. I will show you another small. I need to reduce the sound. Oops, sorry. This was. Okay, so this is the same thing, but with a camera. So there's a 3D camera that looks at the user, and at the moment where the user tries to grab the ball, stimulation kicks in and he grabs the ball, and then the place where he needs to release it, stimulation kicks in and let him release the ball. So this is our collaboration with one therapist in Austria that was just, we've seen it a week ago. So it's very, very new. And it's good. You don't need VR, you just need a camera, and you can do a lot of very interesting things there. So this is, we're very excited about that because you can do a lot of different things with just our devices in real time connected to emotion. So thank you very much.
Thank you. So, very interesting. Any questions? Yeah.
I have a question. Can you embed EMG in this machine?
So in principle, yes. There's it's usually a bit more difficult because EMS gives you 50 volts or 20 volts, and EMG measures millivolts. So you need to very smartly turn one thing's on, one thing's off. In principle, possible, but not not really in the same time. But you're possible. You can definitely. A lot of people do trigger. So people start moving, and when they start, then they start FES. What we do, we're not using EMG. We're using movement. So if person can move by 5 degrees, then stimulation kicks in and continues the movement.
So that's the question I have, which I don't want you to explain because my probably brain couldn't take it. But actually, how you link up the onset of the stimulation with what you're looking for with the camera and the.
So we have different. So for this, the cube thing is just position.
Yeah. Okay.
But not everyone has shoulder mobility, right?
Right.
Some people have almost zero MRC, and in their case they're more passive. So they have they control a bird. There's a bird and. The bird needs to fly high, and stimulation helps them, and bird will fly high. So some of them are passive, some of them are trigger-based. So you need to move for 5 degrees, 10 degrees, 15 degrees, and then stimulation helps you finish.
Then it triggers the actual FES. And I suppose that the physiotherapist in me is thinking, gosh, yes, I can sort of, having worked in neuro rehab, and you think about actually how that will work with repetition over time. And you've shown that it's acceptable, people like it, which is sort of the first stage, isn't it? It's that initial proof of concept. So what's the plan now? Because then the scientist in me is going, but what's it going to do in terms of... So actually, have you designed a study that actually will initially look at effect and to then go on to efficacy trials?
So currently we're doing one session, half an hour. We measure, we see what person is doing. So we track their movement every frame. Mm-hmm. And so we can then do some biophysical measurements. We'll try to do some analysis and probably some ML as well at some point. Yeah. We don't know exactly what we'll do there. Of course, we cannot really see if there is proper improvement. We have some anecdotal evidence that FES has some effect, and you get some additional. So that we know that FES works, and we know that it has some nice effects on certain stroke survivors. So this definitely we know. We hope that connection with movement will increase this recovery. So the next one will be longitudinal, whatever, 3 weeks, and it will require much more effort and more money.
Yeah, it will, but be very interesting.
But we'll do it. Yeah. Mm-hmm.
I'm just wondering, for the real-time camera thing, what sort of cameras are you using?
It's for 3D cameras. Yeah, not just 2D cameras. The 3D Intel something.
Sensor, right?
Yeah, exactly.
Within my role at my workplace, I work in a neuro rehab centre. We're also taking a feasibility style of a similar type device, but doesn't have the setup, such as the VR and games aspect. And one bit we've always struggled with patients is that kind of moving from that sort of meta headset, technically moving from that metaverse to the actual app for which the game-based platform is on. Is that a similar kind of setup with the device that you're using, that you use a different platform and then you move into your software, or does your software come up straight away?
Yeah, it's always the problems are not our technology; it's someone else's. Yeah, but yeah, it's There's there are ways you can have a management software for your headset where you as a therapist just start it, and everyone has access only to this software and none other software. So there's possibility. Yeah.
Great. Thank you very much.
Okay. Thank you very much. So that was our final speaker. So we'd like to thank all of our speakers so much for wonderful presentations.